Hello students, today we learn the third method of finding initial feasible solution, and it is most important method for solving the transportation model because it gives most minimum cost. The third method is VAM method, that is Vogel's approximation method, and it is also called unit cost penalty method. Today we solve very simply manner, that is Vogel's approximation method. We give the same example, that is destination, sources F1, F2, F3. Destinations are W1, W2, W3, W4. Capacity are given and demand is also given. Okay, two methods for solving this Vogel's approximation method. First is to finding in one chart all differences and then get allocation, and the second is for finding first one allocation at a time and then convert the table for next transportation problem. Okay, first we solve for one chart all differences. Okay, for finding Vogel's approximation method to transportation cost, first we check all the cost. The cost are 19, 30, 50, 10, 70, 30, 40, 60, 48, 70 and 20. Capacity and demand are not given in the differences. First we find all differences for corresponding columns and corresponding rows. Okay, the first row which is two minimum elements 19, 13, 15 and 10. Which are two minimum elements? 19 and 10 are two minimum elements. Therefore we find the difference between two minimum values. Okay, the difference between 19 and 10, in this row 19 and 10 are two minimum elements. Then difference between 19 and 10, 19 minus 10, the difference is 9. Okay, we can write here difference 9. Now 70, second row 70, 30, 40, 60, the minimum two values are 30 and 40 in that row. Therefore find the difference between them. 40 minus 30, difference is 10. Right here 10. Okay, 48, 70, 20, which are two values are minimum? 8 and 20. 20 minus 8, the difference is 12. In that difference, capacity and demand does not include. Okay, therefore for solving this problem, we check in this difference capacity are not given. Okay, now we solve for same procedure for columns. Now first column is 19, 70, 40. Which two values are minimum? 19 and 14. Difference between them 40 minus 19, the difference is 21. Therefore we write here 21. Second column 30, 38. Which two values are minimum? 30 and 8. Difference between them 30 minus 8, difference is 22. We write here 22. Now third column 50, 40, 70. Which two values are minimum? 50 and 40 are minimum values. Therefore their difference is 50 minus 40, the difference is 10. Therefore we can write here 10. Now the last one column 10, 60, 20. 20 and 10 are minimum value. Therefore 20 minus 10, the difference is 10. Okay, now see all the differences. The differences are 21, 22, 10, 10, 9, 10 and 12. Which difference are which difference are greater or largest? The largest difference is 22. Therefore we select this column for allocation. Selection is right here by arrow. Therefore we select this column for next allocation. Now in this column 30, 30 and 8 are three values. Then where is allocated our next allocation? The minimum value among them. 30, 38, minimum value is 8. Therefore our allocation is here. Now see the corresponding capacity and corresponding demand. Corresponding capacity is 18, corresponding demand is 8. Therefore minimum allocation is here, minimum value is 8. therefore 8 is located here. Here is 0, here is becomes 10. 18 minus 8, it is 10. Therefore here is 0, therefore in next step this column does not part. Therefore we rough by this column. Okay, you can rub this by pencil. Now next again find the same type differences. First row 19, 50, 10, minimum are 19 and 10, therefore write here difference 9. 70, 40 and 60, minimum values are 40 and 60. 60 minus 40 value is 20. Now 40, 70, 20, 40 minus 20, minimum value is, that is difference between minimum values are 20, therefore write here 20. Same for column 19, 70 and 40, minimum two values are 40 and 19, therefore write here 21. Now is this column, it does not take next step. Okay, you can solve again the transportation problem in that way, and W2 is not included there. Okay, 50, 40, third column 50, 40, 70, minimum values are 50 and 40, their differences are 10. Next last column 10, 60, 20, 20 minus 10, difference is 10. Now again see all the differences 21, 10, 10, 20, 20 and 9. Which differences among them are largest difference? 21 is a largest difference, which is among from first column. Okay, right. Now therefore our next allocation is in our first column. Now 19, 70 and 40, which cost is minimum cost? 19 is our minimum cost, therefore our location is placed at 1 1 position. Okay, or 1 cell. The corresponding capacity is 7, corresponding demand is 5, therefore minimum allocation, what is this minimum value? 5, right here 5, this 5 becomes 0, 7 becomes 2. Okay, 7 minus 5, it is 2, remaining value is 2. Now there is 0, therefore in next step W1 does not takes part. Now remaining values 50 minus 10, value is difference is, again find the differences. 50 minus 10, repeat this procedure up to when our allocation is not stopped. 50 minus 10 value is 40, 40 minus 60 minus 40 value is 20, 70 minus 20 value is 50. Now in the column 50, 40, 70, 50 and 40 are minimum, difference are 10, 10, 60, 20, 20 and 10 are minimum, therefore difference is 10. Again see all differences 10, 10, 50, 20 and 40. Which difference is largest? 50 difference is largest, therefore in next step this row takes allocation. Therefore in that row 70 and 20 are two values, which value is minimum? 20, therefore our allocation is placed at that cell 3, 4. Okay, now among the values here is 10 capacity and demand is 14, which is minimum? Capacity is minimum, therefore allocate here 10, this 10 becomes 0 and this 14 becomes 4. Okay, therefore in next step this does not include. Now again find the differences, only two values are remaining, 50 minus 40, 10, 60 minus 50, 60 minus 10, it is 50, 50 minus 10 it is 40, 60 minus 20, 40 it is 20. See all difference 40, 20, 50 and 10, which is largest difference? 50 is largest difference, and two values are also included 10 and 16. Their corresponding capacity and demands are, here capacity is 2, demand are 4. Therefore here the smallest value is 2, 2 becomes here 0, here 4 becomes 2. Okay, now in next step there does not include. Now only two values are remaining, 40 and 60, which is minimum. 40 is minimum, their corresponding demand is 7, corresponding capacity is 9, therefore minimum demand is 7. here write 7, here becomes 0, here becomes 9 minus here becomes 2, and the last one it is 60, here becomes 2, here becomes 0. When we realize that our last value is same, then our answer is correct. All capacity becomes 0, all demand becomes 0, therefore our value are correct. Okay, and number of locations are 1, 2, 3, 4, 5 and 6. That is m plus n minus 1. That is number of locations are 6. Therefore our values are correct. Now we can solve the total transportation cost. Our total transportation cost is, how can we write? Summation of all values, 5 into 19 plus 2 into 10 plus 7 into 40 plus 4 into 60 plus 8 into 8 plus 10 into 20. Therefore our total transportation cost are 779 rupees. See, in this all three steps, all these three methods, first method is northwest corner method. In northwest corner method our cost is 1015 rupees. In matrix minimum method our cost is 814 rupees, and in Vogel's approximation, that is VAM method, our cost is 779 rupees. That is minimum cost. Therefore this Vogel's approximation method gives us the minimum cost to minimize our transportation cost, and which is mostly used and applicable method, and it gives near about the optimal solution. Therefore for finding optimal solution, the mostly used method is Vogel's approximation method, that is unit cost penalty method. Okay, thank you.